So welcome, Peter, and thanks for attending. I'm sorry about the technical difficulties, but would you like to go ahead with your presentation, please?
So I'm Peter's colleague from Frazer-Nash, so I'll just give the voiceover for Peter's bit whilst he struggles with the technology, if that's okay.
Yeah, well, thanks very much. That'd be helpful.
No problem. So my name's Clement O'Rourke. I work for Peter. So what we've developed is a whole course model to consider the effects of policies on the health, the economy, and outreach of various regions around the UK, and seeing how they're affected by policy and interventions. There are three streams to the model. There's the infection model, which is based entirely on the Imperial College model. There's the business survival, which is calculating when businesses will fail, and then job losses and gross value added. And then there's an outrage model, which models and estimates how the potential for outrage is building within the population. As I said, it's a regional model, so it considers the 12 administration regions of the UK plus England, and it allows you to consider the effects across the whole of the UK if you wanted to. The regions are done entirely for data purposes. We can change the size of the regions easily, provided we can get the right data for it. For the business survival, we consider 17 different industrial sectors that the UK government uses currently when they compile data. And the model allows the user to change the scope and timing of policies to see how these affect the end results. The model is a Bayesian network, and it takes data from various sources. So it takes a lot of ONS data, British Chamber of Commerce surveys, and as I said before, the Imperial College model. This approach we've used in a large number of applications where you're trying to predict whole costs for investment decisions, and it allows you to understand the uncertainty quite quickly. The model is set up to be run in quite a quick way, so you can change a policy timing or change a policy size or effect and see the results fairly quickly. So it's somewhat of an aggregated model. The version I'm going to show you now is calculating infections on a weekly basis and economic effects on a fortnightly basis. That's all user changeable and user config. I've just kept those values arbitrarily high just so we get quicker run times. But when you bring those down to about a day, we're talking about a 5 to 6 minute solve. So that's a brief overview, and that's, I think, a summary of what Peter's slide says there. I was just going to shift over straight to showing the front-end interface now, if that's okay. So hopefully everyone can see this front-end interface here. So this is what the front-end model looks like. As I said, the main focus is largely around the framework we developed. Some of the input data is almost certainly a bit out of date, as it's what we've been able to find publicly online. But to start with, you have the policies at the top. So we've got 12 or so different policies. The ones at the top are generally around public health, and the ones at the bottom are more about business support. These are all user definable. From the front end, you can just define the start and end date, and that allows you to play quick tunes on the model. But you can actually, in a back-end Excel spreadsheet, you can change the effect on a wide number of different parameters. So the Gantt allows you to see when different policies are taking effect, and then you can see the results on a regional basis. So we've got the 12 different regions you can see here, and then you can plot a large number of different variables and see how they vary through time. By default, we've got plotted the 10 percentile, 50 percentile, and 90 percentile of all the results.
Hello.
So starting at the very top around the infection model, we can see that you can see the R factor coming through, and you can see that there's a large rise in R factor with when lockdown ends at around 220 days. See this big increase. You can see the smaller effects as you go through time on the other parameters, and that corresponds to these parts here. The R factor obviously then leads to infections and how the infections change through time. The case I've got here has got a lockdown ending after 220 days, but the calculation running for another 80 days afterwards. So unsurprisingly, you get a large rise in cases afterwards as the pandemic takes hold and you get a second wave. And again, you can see those on different region levels, including England. Infections are turned into deaths using the lag terms in the Imperial model. As I said before, the Imperial model data we've got is what's publicly available, so it's probably a bit out of date. So these numbers might be a bit different to what you expect. But again, that's all a simple back-end change you can make. But it allows you to then see how deaths are varying from region to region. which then is in the same basis as having the economic model and the outrage model. So moving on to the outrage, onto the economic model. The model is essentially a prediction of how a business's cash will vary through time, and it's taking into account a number of different factors which influence that. So it looks at your starting cash based on survey data. It looks at the proportion of staff which are currently on furlough and how much they're being supported by government policies on furlough. It looks at the effectiveness of working from home on a sectoral basis. It looks at simplistic pricing and demand inputs. It looks at the level of sickness from the infection model. It looks at the effectiveness of working on site, which are again affected by policies. And it looks at loan support facilities and government policies on tax holidays. And you can see through here, I'll just zoom in a little bit more so it's a bit easier to see. You can see around 120 days as a drop in the cash flow, and that corresponds to a loan facility closing out at 120 days. It's all done on a sectoral level, and you can see all the different outputs from there. So you can see the proportion of people who are working from home in this area, which is production. We're assuming that 20% of people work from home until lockdown closes. You can see the effectiveness of working on site, which slowly increases as various policies are reduced, with the largest being when social distancing is reduced. And that all corresponds down to the high level number, which gives you the number of unemployment, so the number of people who will lose their jobs through time. And again, it's done at the different uncertainty levels. And you can see those results on different region levels. So you can see different regions have different effects depending on what the size of the manufacturing base is for this example. And it's all done on a sectoral level. Those numbers then aggregate up to provide you with the total number of businesses which will fail, and then the total increase in unemployment as a total number and as a percentage. And again, that's on a regional level, and it's based on how different sectors in different regions are affected by the different policies. You can also then use that to aggregate up to GVA, which we've estimated up here, which is just showing how the proportion of GVA will vary through time, and you can see it's not a particularly pleasant picture. The final thing I was going to talk to you, the third thing we've modelled is outrage. So how people respond to policies is important in terms of how they will comply in the future. It's quite a difficult area to capture in a mathematical framework, but we've lent on Peter Sandman's work, which has been used in the nuclear industry and other places to predict outrage. What we're really predicting here is not necessarily outrage as observed, but more the potential for outrage in the community. So different events will lead to a spike in outrage, but it tells you what is the underlying tension and pressure in society. The outrage is made up of three proportions. So you have the effect of health, which is how many deaths are currently ongoing in the community. And as you get more deaths, the outrage rises. As you have less deaths, there's less outrage about health. For economics, you have it's all linked off the percentage unemployment with a log sigmoid, so you don't get overwhelmed by the overall effect. But you can see the outrage gets very high as you get towards as the unemployment gets quite large in the area I'm looking at. The final part is the policy, and this is based on survey data of how people will respond to the policy. So it's looking at how various policies have ranked in terms of the fairness and how effective they are, sees which ones of them are in implementation at the moment, and then it scales by regional effects based on demographics, wealth, sectoral basis, and population density to give you how each region will feel about each different policy. And as you can see through time, the policy outrage decreases because by the end of the simulation, we only have one policy outstanding still, which is self-isolation. The combination of these is the total outrage, and it's just the product of those three signs, and it shows how the overall outrage is growing. So in this, you can see it starts reasonably low, and that's because there aren't very many deaths. There isn't very much unemployment at the start of the simulation, but there are some lockdown effects. As the unemployment rises, you see an increase in outrage. As the more features are released, you see it reducing further and further, and then as deaths start to pick up after lockdown's released, you see a large increase. So that's a quick run through of all the things we can present in the model. What we can also do is we can just change when events happen. So in the scenario I've just taken us through, we've seen quite a lot of businesses fail. So we could go, well, what happens if I increase that loan support by another 150 days? And we're getting a rise in cases. So let's change when lockdown goes to 250 instead of 220. So you just change those, you press go, and then we wait for it to solve. This is at the moment a alpha version of the code, so it doesn't have any nice wait bars whilst it waits for it to solve. So you just have to hear me talk for a little bit whilst we wait for the interesting results to come back. But we are planning to push this onto Azure, and we're in the process of doing that, so people can log on and start to play with it. What we're keen to know is how people view it, how people see it could be useful, and what extra information they've got. As you can see in the drop down, there's a huge amount of different types of information we've got in this model, and it can be cut in a number of different ways. We also have as a list of things we want to try and improve in the back-end model. So in the economic model, we want to improve the pricing and demand side using input-output tables and taking into account import-export parameters. We're also really keen to try and, in the health model, expand it to include not just COVID deaths, so looking at the effect of social deprivation, so feeding in the fact that you've got localized unemployment, which will lead to other health effects. Also keen to try and include local hospital capacities to the infection model. Again, we want to be steered though by what is out there. We want to try and use as much as other people's work as possible to try and provide an aggregated tool. And we also want to try and put in things like the number of recovered people, because I think that's a useful parameter. All right, so hopefully this is now run. So if we have a look at the R factor. Yeah, so you can see, so we moved the lockdown from 220 days to 250 days. So the R factor has changed from rising at around 220 before to rising around 250. Which if we then look at new cases, you can see there's significantly fewer. We're in the millions before, now we're in the tens of thousands. And then you can start to see, if we look at, where's the production one gone? Production unemployment, what's construction, sorry. This number is quite a lot less than it was before, and that's the effect of the increased loan support, which helps businesses to survive for a bit longer. So that's pretty much a very whistle-stop tour through what we've developed. Has anyone got any questions, or would like to see anything else on the model?
So I have a question or two. So you said that the EPI model is based on the imperial model. Can you say more about what actually is going on in the epidemic modeling thing that you have living in the middle of this?
Yes, so it's got cases at each time, new cases at every time. It has the infection lag from the imperial model. It's got the death lag as well. So it looks at the summation of the number of cases on each of the previous days times by the infection lag times by the R factor to give you the number of cases on the day you're currently solving for. And then deaths for that day are then calculated in the same way. So it's the death lag times by the death factor times by the number of new cases on those days in the past.
So I'm still not quite clear what model that actually is.
So we've taken what was written in I think it's report 13 from Imperial College.
Go on.
So that's the basis of it. So it's
I'm trying to remember which model is in report 13. I thought that was the big model, isn't that COVID sim?
No, it's not.
It's the Bayesian little one, is it?
Compartment model.
Okay. So it's the Imperial's preferred compartment model, which is regionalized by them. Is that right? Graham, do you remember?
Yes.
Okay, that makes sense. And that's why you were able to run it in about 20 seconds.
Yeah, exactly. So that's why it's able.
So there's more than one Imperial model, which is why I was confused.
Apologies.
Okay.
Yeah, I think one of the things that we will be looking at doing as we develop further is clearly getting the latest version of model and data to be able to feed into the model. At the moment, we're using so what is available open source.
That's good. So, yeah, Clem, could you stop sharing your screen maybe if we're
Yeah,
moving into the discussion? Right, thank you. I had a comment sort of complementing that, which was how hard would it be to set out how other people with models which are purely at the moment epidemic could add in the economic aspects? I mean, it seems to me that people who are doing epidemic modeling of the pandemic will already be likely to be modeling the sort of epidemic interventions, the effects of lockdown in various ways. So it would be suggesting to them that they could add on the business interventions and of course the economic measurements related to them at the same time. I mean, am I right in thinking that really it's it's only the epidemic interventions that are assumed to be changing the way the actual epidemic runs? Is that right?
Yes. So for each policy, you define an R reduction based again off that report setting.
So in a sense, then the whole economic bit is something you can sort of add on potentially to anyone's epidemic model conceptually without too much difficulty. I mean, it might be an awful lot of, could be a lot of work, but conceptually it would be.
I think the way I would say it, Dennis, is more that you can introduce other epidemic models within the whole cost model is a relatively straightforward thing to do.
Yeah, well,
there is a little bit of work to be done, but
yeah, but I think that's the other way of putting it, Pete. Exactly, that you can marry up that because they don't interact in a particularly complicated way. It shouldn't be too difficult once you have the sort of pattern for how to do it to match up your preferred kind of anyone's preferred kind of epidemic model with this kind of economic intervention modeling.
correct. And if you take, for example, the lockdown, there are two elements to that. There is the lockdown for people staying at home, and there is the economic sort of compensation that the government has put in to make it possible for people to stay at home. And yeah. So they're two different but related policies. One to try to control the virus, the other one using cash to be able to keep businesses alive.
Yes, it's sort of regulations and support.
Correct. I mean, what we're looking at within the modeling, because we have these sort of three streams, we're looking at the flow of the virus, the flow of cash through the economy, and the flow of trust in the people. And it's a matter of balancing those, and any sort of policy will have an impact on those three streams.
Okay, got a couple of questions, I think. Ewan.
Yeah, I guess I'm just a little bit worried that, you know, modeling the effects of both macro and microeconomic interventions is notoriously difficult. I mean, it is exceptionally hard to know that, you know, if you give your average business £10,000, what actually happens to that business? I'm wondering if, you know, and secondly, of course, this is not a static set of interventions. As the pandemic inputs into the economy then changes, and that changes the pandemic, and the pandemic then changes the economy, and it's a very non-linear and interrelated system. And I'm just not sure how far you can actually take this without just introducing lots of extra uncertainty.
Yeah, I think the way I would respond to that is the approach that we've taken is in the same way the infection model is looking at the infection and survival of people. The economic model is based around the survival of businesses. And there are different businesses, different sectors. There are about 17 sectors that we've considered. and it's essentially looking at the effect of cash flow. I mean, there's the markets, the supply chain, etc. But whether or not a business survives is determined by how much cash it has. And so that will then give you an indication of job losses and an indication of effect of GDP. Now, it is limited. We're not trying to model a complete economy, but in the same way that the infection model gives you an indication of deaths and recovery, this will give you an indication of some business recovery, and also the scope for recovery once a lockdown is eased. So it's not pretending to model the economy entirely, but I think by focusing on the business survival and cash side of things, it gives a reasonable idea, certainly in the short term. And at the moment, we're looking at what happens in the next months up to a year, as opposed to what are the long-term effects.
Thank you. Graham, you had a question.
Yeah, I wondered, is it possible within the model to optimize the interventions to reduce the whole cost automatically, or do you just have to play with the various levers and see which ones push it down?
I think the short answer is yes. I mean, at the moment, the model that Clem has presented is the first cut of the model, and that allows you to change policy and intervention and see the effects on cost. The nice feature of the Bayesian network approach is you can go backwards and forwards through it, and so being able to operate from the other side by saying this is an outcome we want, what sort of policies would lead to that, and then introducing a optimization part within that would allow you to do sort of optimization of what you should do for best outcome. But that is the sort of next step of the modeling. I think in defense of the team, what you've seen today is being put together in a month. It's on the back of an approach which has been proven in a different and very uncertain industry. But you know, to get a sort of a tool to this stage in a month, I think all of us will appreciate it. It's pretty good going.
Yeah, I'm not trying to criticize that, more
No.
make a
I just
connection with the
to
next talk that's coming along.
Yes, so the short answer is it doesn't at the moment. Being able to operate two-way is inherent within the model, and then introducing an optimization of that is certainly on the plan.
Something I realised that we didn't mention is that we're interested in looking at how you can feed back that outrage potential into compliance of various features. So as you start to, just from my own personal view, walking around, I've seen people be much less careful about social distancing, and that seems to be grown by the fact that they don't see the risk as being as high anymore, and they're less angry by they're angry by the loss of freedom. Factoring that in is something which I'd be very interested in trying to add in the next stage of our development. So the next week or two, I think, is where we'll look to try and get that sort of feedback in. Yeah,
we've got we've included the ability to include modifiers as a result of outrage, but in the first cut of the product, we thought it was probably best to leave that and develop over the next couple of weeks.
Can I just add to that? Because it's not only outrage. I mean, it's also logic. You know, if the infection rate is very low, the personal gain is to not bother with social distancing because your personal risk is very small, but you're still putting R above 1. So it's not only outrage that makes a link between the decay in the prevalence of the disease and people's willingness to make the sacrifices because their personal risk is proportional to the number of infected cases, not to R, but their behavior gives you R. So I think that feedback is an interesting one, but I think to be honest, I'm not sure your use of the word outrage for this kind of social part of your model. To be honest, I think that you might want to change that because I think there's more to it than that. And I think that's a slightly provocative word, particularly if you want the kind of thing that you've shown us to be adopted by the kind of people who run the country.
Yeah, no, I think it's a point well made. I think the reason that we've used the term outrage is because there is a sort of academic background to it. It has been used in a number of applications around the nuclear industry, where there is a high level of perception of potential problems with nuclear. Outrage is really an indication of how much people care about things and how much they sort of trust what they're being told, how anxious they are about things. So, but I agree. I think if you were to present outrage to the politicians, it's not an easy one to push in terms of the public.
Do you have any other questions?
Well, one more question is that in terms of the Bayesian part of this kind of surrounding wrapper, so Dana was sort of saying, well, you could in principle wrap this around any epidemic model. Does it matter to you how Bayesian the epidemic model is? Or is that really just a subunit that could be anything?
In terms of how it feeds back into the model, provided the outputs come as a distribution, what happens within that model doesn't necessarily matter too much to us.
But you do want you want the output of the epidemic model ideally to be posterior distributions of things, not just a sample.
Yeah, ideally.
Yeah. Okay, thanks.